Have you ever really stopped to think about what's going on behind the scenes of your favorite apps? Well, today we're going to pull back the curtain and explore the invisible architecture that powers all those real-time features we kind of take for granted.
Right? It's not magic, but it is a pretty fundamental shift in how software is built. See, we've moved away from this old-school method of creating one giant block of code to building a whole network of small, nimble, independent services. To really get how we got here, we need to rewind a bit and look at how things used to be done.
So let's start at the very beginning, with an approach that's foundational, but let's just say has its issues. It's called the monolith. Imagine you're building a simple to-do app. Now, in a monolithic world, everything, and I mean everything, the buttons you click on the screen, all the business logic, how it talks to the database, it all lives together in one single giant piece of code. It's all just one big interconnected unit.
Now look, this works just fine for a small app, but as it starts to grow, it becomes a massive headache. If you want to update one tiny little feature, you have to redeploy the entire application. A bug in one small part can bring the whole system crashing down. And over time, the code just becomes this tangled spaghetti mess that's almost impossible for teams to work with.
So to fix all these problems, developers started moving to a totally new model, microservices. And this is where things start to get really clever.
The whole idea here is to just break up that giant monolith. So instead of one big to-do app, you now have a separate, totally independent service for just the user interface, and a different one for the backend logic. Each little piece is small, it's focused, and you can manage it all on its own. You know, this whole process is called decoupling, and it is an absolute game changer. It gives different teams the freedom to work on their own little piece of the puzzle. The front-end team can use Next.js, the back-end team can use Fast API, and they can do it without constantly tripping over each other.
Okay, but all this newfound freedom created a totally new challenge. I mean, if you have dozens, or maybe even hundreds of these little microservices all running around, how do they talk to each other without creating a brand new kind of tangled mess? Let's switch gears to an e-commerce app to make this really clear. When you go online and place an order, it's not just one thing happening. Behind the scenes, a bunch of different services have to work together in this perfect, rigid sequence.
So just look at this chain of events. The order service has to directly call the payment service. Then, the payment service has to turn around and call the distribution service. They're all chained together, each one just sitting there, waiting on the next one to finish.
And here's the kicker. This tight coupling makes the whole system super fragile. If any single service in that chain slows down, or worse, fails, the entire process just grinds to a halt. Your order fails, and you're left staring at an error message. It's frustrating, and it just doesn't scale when you're talking about millions of users.
This is where the hero of our story comes in. It's a massively powerful tool called Kafka, and it introduces something called an event-driven architecture, which completely flips the script on how these services communicate.
The best way to think about Kafka is like a central post office for data. Services don't talk to each other directly anymore. Nope. Instead, they just send messages to the Kafka post office, and then other services can come and pick up those messages whenever they're ready. This creates something called loose coupling. It's a huge deal.
And the messages they're sending are called events. An event is really just a simple record that something happened. That's it. A customer placed an order. That's an event. A user added a to-do item. That's an event. A payment was processed. Event. So instead of services asking for information, they just announce to the world through Kafka, hey, this thing just happened.
So to really wrap your head around this, you just need to know three core concepts in the Kafka world: producers, consumers, and topics. Okay, so here's how it flows. A service that creates an event, like our order service, is called a producer. It sends or publishes an order-placed event to a specific channel in Kafka called a topic. We could just call it the orders topic. Then you have other services, like the payment service, that act as consumers. They just subscribe to that order's topic, and they get notified the instant a new order event shows up.
All right, let's put this all together and see how this asynchronous communication builds a much stronger and more resilient system for our e-commerce app.
So with Kafka sitting in the middle, the moment you click Place Order, the order service does one simple thing. It fires off an event to Kafka and immediately tells you, hey, we got your order. You weren't left waiting and wondering. Meanwhile, in the background, the payment service and the distribution service independently pick up that event and start doing their jobs. It creates this incredibly smooth, fast user experience.
So why is this such a big deal?
Why does this loosely coupled, event-driven approach totally win in the real world? Well, this architecture is just incredibly powerful. Is your payment service getting slammed with traffic? No problem, just add more consumers to handle the load. What if the distribution service goes down for maintenance? Again, no big deal. The order events will just wait safely inside Kafka until it comes back online. The key is, the order is never lost.
And when we talk about load, we are talking about massive, massive scale. Kafka is built for insane performance. It can process millions of events per second. That is way more than a traditional database could ever dream of handling for this kind of real-time data streaming.
So, the next time you're watching your delivery driver's little car icon moving across the map, or you get that instant order confirmation, you'll know it's not magic. It's this powerful, event-driven architecture humming along tirelessly behind the scenes. And it really makes you wonder, doesn't it? Which of your favorite apps would just completely break without it?